Hey, how you doing? Sean Tech here again. Hey, thanks again for all the support and everything that's going on within everything that we're working on with the YouTube channel. Today, I wanted to get a little bit more on the electronic side and start talking a little bit about something called fluxing agent. You've seen me use it a whole bunch of times. You've seen some of the work that I've done with it, and ultimately, if you're doing anything with respect to surface mount technology, SMT soldering, it's sort of a requirement because if you're going to try and do anything with SMT, and I mean like anything, without flux, it will make things extremely difficult for what it is to do. Most especially when it comes to using anything with respect to lead free technology. So, in a nutshell, some electronics are soldered with lead based solders. Other electronics are built with soldered together using lead free solder. More specifically, lead-free soldering is considered to be more difficult than regular soldering for a number of reasons. Number one, it takes a higher temperature. Two, it has less wettability, most especially less wettability without actually being able to solder a component down. And number three, if you want to sell your appliance in, like, for instance, in Europe somewhere, they'll only accept it if it's got lead-free stuff, and that goes for a lot of appliances. Nobody wants to take their cell phone, hold it up, and know that there's lead-based technology or lead-based things on the inside that are right next to their ears, or have something, a biomedical thing implanted on the inside of you, knowing full well that uh, that the that there's lead inside of you. Nobody wants that. Nobody likes that. Nobody thinks that's a good idea or anything like that. So, but anyway, what I wanted to do today is to kind of review and show you kind of what it is that lead-free technology ultimately kind of is. One of the things I'm going to be doing is I'm going to be sort of reworking two open pads, both here Q1 and Q2 on the microscope. These are going to be for transistors, which I actually have here in a little tape and reel. First and foremost, though, make sure that I am ESD grounded. It's one of those things that, if anywhere in manufacturing, it's one of those things that just kind of helps. Even though these transistors, these guys are pretty rugged and stuff, I don't have to worry too much with it. But good practices never hurt. You can never get enough with good practices. The ability to sort of be able to do things over and over and over again within the right way. Because even if I don't electronically zap these transistors, even if I do electronically zap these transistors, they are still could potentially have a chance of, well, even if I do zap them, they could probably still survive. These guys in particular would very likely still survive. So that being the case to it, though, there we go. Okay, so those two transistors are going to be going here. I'm not sure what kind of transistors they are. Probably some sort of a bipolar junction transistor. If I had to guess, it's one of those common ones, like a 2N3904 type transistor. It's one of those common ones that us teaching folks just sort of buy from time to time. Anyway, first thing that I'm going to do is I'm going to focus on Q2. Q2, just over here on the uh, left-hand side, is going to be the position where I'm going to attach this transistor to this location here without the use of a fluxing agent. And I'm actually going to, first thing I'm going to do is remove the lead-based solder that is actually already there. I know this is sort of a cardinal sin. It comes to, like, well, there's already lead on it. Why don't you just use more lead? Well, that's actually pretty true in a lot of ways. So I'm going to, this is more for just for demonstration purposes more than anything. Normally, you start with lead free, and if you have to move to lead for whatever reason, then you go for it. You don't start with lead and then move to lead free, because there could probably still be lead. I'm not going to remove every single atom. So I'm going to use some solder wick and my soldering iron, which is currently set to 690 degrees Fahrenheit, and I'm using my wick to essentially absorb some of the, oh gosh, look at that. Look at that solder. Look at that gunk that's sitting on there. Can you see that okay? I want to make sure that you can actually see what it is that I'm working on here. Let me adjust the gain just a little bit here. Maybe a little bit more. Try to go up so I can keep my exposure rate where it is there. Make sure that I am, for the most part, in focus on Q2. There we go. All right. And now I'm going to go to the next area here. Apply my soldering iron set to 690 degrees Fahrenheit. onto the pad. And what this wick is doing, the wick is heating up, and the wick is made of copper, which will absorb lead into the copper strand as it begins to heat up. And ultimately, what this kind of does is it removes. What it does is it removes the copper, the solder from the open pad. So if one were to look at the difference right now between the two of them, outside of the gunky difference, the pads that are on Q2 are cleared of their solder. Wick is an important tool that's used for basically removing any of the solder and starting kind of over from scratch. What I'm going to do now is kind of clean up my area, because I'm going to attempt to do this without fluxing agent, with lead-free based solder. Ugh, and it's already begun. See that gunk right there? I don't know what that gunk is, but I don't like it. Slowly but surely, it is coming off using my isopropyl alcohol cleaning solution, electronic grade stuff. That is. There we go. So it's slowly but surely coming off. Can you hear that sound? Squeakity squeak, squeak, squeak. I don't know if my microphone is that good at being able to pick that up, but I don't know what the stuff is, so I'm just going to do a thorough job at being able to try and remove all of the stuff that's there. I'm going to grab a wipe. There we go. Wipe that area clean. There we go. Okay, so now what I'm going to do is I'm going to take my lead-free solder and tin the tip of my soldering iron with it. So I've got my soldering iron here. What I'm going to do is I'm going to apply it to the tip, and you might see some fumes to show up. I believe there is still inside of my fluxing agent right now a rosin core. I'm going to make sure that my fume extractor is also on as well. One of those nice things to be able to have at all times to make sure that you have fume extraction occurring. And now it's time to attach the transistor. So I'm going to make sure that you can see what I'm doing here. All right, there we go. There we go. Attach some of the solder. That you could tell right away that it's lead-free based solder, because after I take my tip away from it, it turns to a nice dull gray in color. Now you compare that, say for instance, to, and I'm going to try to focus in as best as I can on one of the lead-based joints, where we can see that they are shiny. They are shiny and lustrous, and when I melt them, the whole thing melts down, and it remelts again, and I've got a nice, for the most part, a shiny surface of which it turns to a shiny color. Now compare that to the rather almost matte finish looking color, or matte finish looking texture of the lead-free based solder joint. You can definitely tell it looks more matted, duller, and grayer is what it actually looks like in particular with it. So yeah, so that's what that looks like there. So now what I'm going to do next is move the soldering iron from my right hand to my left hand, take one of the transistors, and I'm going to tack one of the ends down of the transistors using lead-free based solder. So I'm going to come in here. There might actually be a better tip for being able to do this with. I'm currently using a much larger tip that's more or less used for wicking. If I wanted to be better about it, I could actually use a better solder tip to it. Hopefully you got a chance to see what that looked like there. So there you go. There's my lead-free based solder. Not too bad. Not too bad. Let me try and touch it up just a little bit here. Try and give it a little bit of a touch up. Come on. How about a little touch up? Come on. Come on. Come on. Come on. Nope. It's doing the little stalactite thing with me, which will happen. It will definitely happen without the use of fluxing agent. Now we're going to switch back over to the right hand side. I'm actually going to rotate this around a little bit so I have better access at getting to the two pins which are currently at the bottom of the transistor. So now I'm going to come down to here, and I'm going to heat up both the pin and the pad with my soldering iron set to a fairly high temperature. And that is a lot of solder, but that's okay. should form a nice meniscus here. Again, I'm not entirely using the best of joints with that one on there. That is not too bad in terms of where that is. That's really not too bad where that comes with. So there you saw, and I am actually at an elevated temperature, which in some ways is not entirely fair. I have to be at an elevated temperature for doing lead-free based soldering, but at the end though, that's what my joints sort of look like. Now what I'm going to do is use another swab and some isopropyl alcohol and sort of clean this up to see what this sort of looks like at the very end. And it definitely has got the ones that are on the right hand side look a little bit better than the ones that are on the left hand side. All right, so looking pretty good. Looking pretty good there. It's not too bad. All considering I'm not using fluxing agent, I'm actually kind of impressed with myself on that one. That's pretty good. Now let's actually move on to a place where I actually am going to use fluxing agent. So fluxing agent is going to provide a couple of things. One, it creates a better way for the solder to be able to join up to the joint. Two, it's going to remove any oxidation and even some skin oils and other contaminants that often interfere with soldering. And number three, it's going to, if I've got components around it, I don't have any components around this one, it will help to protect some of those other components from also oxidizing, while if I'm working on this one here, that really more or less applies to hot air more than anything. So now what I'm going to do is I'm going to bring my solder wick back in, bring my soldering iron back down, and remove the solder from the pads here. Wait for me to get up to temperature. And there I am. I'm at 690 degrees Fahrenheit. And now begins the process. You might notice some additional fumes. Those fumes is the fluxing agent that is reacting with the surface that I am working with here, and it helps to absorb it just a little bit faster. I have my snips here. I do. I have my snips here, so I'm going to snip off the excess piece of wick. Wick is a consumable. It ultimately does get consumed up. You don't want to keep reusing the same solder wick over and over again. Definitely don't want to keep doing that. All right, so now we'll use the my Q-tip is getting a little bit messy. It's okay though. So I'm going to do a nice thorough job at cleaning up the area. Okay. A little bit more. Want to make sure that all the stuff is gone. This especially becomes important when working on things that have multiple pins to them. Do I have a little wipe or so? Oh, it's sitting underneath my Hako fume extractor. There we go. All right. That looks pretty good for Q1. Q1 is what we're going to use fluxing agent for to tack this down again. So I'm going to come in here and apply a whole bunch of fluxing agent down. I'm going to flip my board around because I'm right-handed, so I solder the left hand part of the pad more often than not. Let me bring that down so that you can all see it. There we go. Okay, wait for my soldering iron to get up to temperature, which is currently at a temperature of about 690 degrees Fahrenheit. There we go. Okay, you see the fluxing agent has reacted slightly with the heat applied from the soldering iron. Okay, I'm going to come on down. Oh, those are not the usual. That is not the pair of tweezers I thought they were. And I have lost my... Oh, nope, there it is. He tried to run away from me. Did you try and run away from me, you silly little transistor? And look how nicely that flowed over the joint. You see how nicely that just kind of found the right area and crept right up the side, forming a very nice meniscus to the side of that joint. And it did so very quickly. And the other one, I'm like, gotta make sure that it kind of helps stick there, and I gotta make sure that the solder is going up and onto the lead of the joint. I don't want to just let it. I absolutely don't want to. I don't want to blob up a bunch of solder down on my soldering iron and just touch it down to the pad. In hobbyist type of circuit boards, that will work. You'll create a connection, sort of, maybe, even in some cases. But in manufacturing, that's an absolute no-no. In order to get solder to bond up to both the pad that's on the bottom and the lead that's actually on the top part of the chip, you need to make sure that they both get up to temperature so that the solder can interdiffuse with both the material that's on the lead as well as the material that's down on the pad. You have to do both of those together. And fluxing agent just helps to make that faster, is really what it kind of does. Now I'm going to move it to where Q1, those two leads are ultimately on the bottom for me, so they're easy for me to get to. I'll tell you what, because fluxing agent is cheap, very, very cheap. The fluxing agent that I purchased is something around the range of like a 30 cc syringe of the stuff costs something around like $14 or $12, something like that. Very inexpensive, and at the same time, very effective. Something I myself, if I'm working with surface mount stuff, I have to have. It's necessary in some of the cases. It actually helps in several other ways when you get parts that are ultimately really, really small, which we'll be doing videos on at some point when we start to solder up components which are ultimately pretty dang small, is where they're at. All right, so now I'm going to come down. I'm going to activate the fluxing agent, and now I'm going to come in with my solder. And you see how nicely that flowed onto the pads. I'm heating up both the pads there, and there you go. Easy lemons. Easy lemons. Gonna take the, might be a previously slightly dirty Q-tip, but that's okay. Still going to use some of this to help clean up what my joint looks like. Put a little bit more down. Try and do a nice compare and contrast both components, which I'll dry up here in just a little bit. We'll take a side-by-side comparison. There we go. And okay, so taking a look between these two, which one looks better to you? Which one was faster as well? You gotta think a little bit about that. Q1 was definitely faster and easier to do compared to Q2, and more natural as well. It's one of those things to where it just sort of flowed onto the transistor, is what it did. It flowed onto the leads of the transistor, and did so efficiently. I didn't have to wait a lot of time for that to happen. There is a kind of a side profile view of what both transistors kind of look like, and you can definitely tell that Q2 on the left-hand side definitely still has some problems. Not to say I couldn't fix those problems with a little bit of some fluxing agent and a little bit of some reapplication of the heat of the soldering iron. Honestly, is what it is. So if I apply just a little bit more of the fluxing agent down, and then I take my soldering iron, I'm going to take it in my left hand just because it's okay. Wait for it to get up to its temperature. Kind of zoom into the part so that you can all see that okay on the screen. And I'm going to come down, activate the fluxing agent, and in one hit of that soldering iron at this temperature, and it's fixed. It's just that easy to really be able to do with fluxing agent. Same thing on the other side. Was I worried about the other side? Well, not anymore. They're fixed at this point. Now what I've got here is a much, much better looking transistor, especially that connection that was on the left-hand side. Much, much better. So, anyway, hopefully you got a chance to learn something new or review something that you may were just interested. Surface mount technology, fluxing agent is the secret sauce, and is something that you definitely want to be able to apply and put down when you can. What do you think? So leave any questions, leave any comments, email me anything. Leave questions, comments, anything like that. Do you want to see more things along the lines of like this? We are going to actually start to build up a couple of circuit boards at some point here. I've got one in mind, and we're gonna. Actually, I've got several in mind. I've got several other kind of stuff. I always have, I'm a pet shop of hamster wheels. I've got like 30 of them all rolling around somewhere inside of it right there. It's a mess. side of the head. So anyway, let me know in the comments below if you want me to work on anything in particular. I'll see what I can scrounge up around my house. I've got a lot of stuff that I've ordered in, stuff that I can order in, get in, that kind of stuff. So thanks very much for coming to the show, and we'll see you around on the next one. All right, see you later. Bye-bye.